Be back in Ottawa. It's already 3 years since I returned to Rimouski. I remember the good meeting we had, the observers group meeting we had every month. I must say that since I returned, I have, even though I became president of the RASC, it's a great honor for me. But I managed to do some astronomy. After I returned for my first year back in Rimouski, I did not have an observatory. So we had a new home, so I had to, like any of you who someday went into a new home, you know, we have a lot of things to fix. But the second year, I told my wife, it's my time, and then I built a new observatory. So before my real talk, I'm going to show you some pictures of my my new observatory, the eclipse, and then the real talk. So since I have many pictures to show, and most of my presentation is around those pictures, I believe we'll start right away with the pictures. That is my old observatory, which I built in 1976. Many of you certainly will remember pictures, and Robin Molson, for one, will remember the place because he visited. We made astronomy there one night until very late in the morning. Initially, it was white. I wanted to keep it cool. But eventually I painted it green, so it would attract much less attention. So incidentally, I have used that site 9 years, and I never had any problem at all. So I am tempted to try to drive the slide with that, but this is not it. So next slide, please. Here we see my main instruments. An old Dynamax 8, which is, optically speaking, the equivalent of a Celestron 8. But mechanically speaking, it was a much poorer mechanics. And after all the pictures, he has been taking, my Schmidt camera has been piggyback on it for all the pictures I took with my Schmidt camera. Probably over 2,000 so far. For my sky survey alone, I took close to 1,500. And of course, I took many more beside that. And I'm still taking pictures. But I am not working on that atlas anymore because I feel I have worked enough on it. Now I concentrate on what I would call interesting object in the sky. Or I should say patches in the sky, because that Schmidt camera has quite a large field of view, about 6 by 8 degrees. So the small planetary nebula don't show up very much on it, so it has to be extended object. But it's quite surprising what we can do with such a small instrument, as you will see. Next. So this is what Rolf was trying to say, how much snow I could get. So sometime, of course, I had to travel a bit before I could start actual observing. So, but it was fun going there. Next. I had visitors on above time, so I believe you can remember all those people. Leon Wright from Kingston, I met last night. Peter Jedicky's wife, Diane, myself, about 12 years younger, and of course David Levy. Next. And this is what was left of my observatory when I came back from Ottawa. When I left Rimouski in winter '85, I asked the farmer if I make a deal with him. I gave him my observatory. I knew he was not going to make observing, but I thought he may want to do something with the small building. And part of the deal, when I was to came back, because I knew I was to come back to Rimouski, I wanted the site back. He said, no problem. When you come back, you can get there. Unfortunately, he sold his farm meanwhile. So when I came back, the new owner did not agree, well, or maybe he wanted much money. But eventually a friend invited me to go to his place, where I am now. Next. So that is my new observatory. This one is white and is going to stay white because it is in the open. Everybody see it from the road. But there are good neighbors who keep an eye on it. It's just on the side of a lake. We see at the back. Only about 10-12 minutes from home. This is not far, but Rimouski is only about 40,000 people. And the observatory is southeast of Rimouski. So the west-southwest is, no, the northwest is a bit bright, but about 3/4 of the horizon is very good. So this is quite acceptable. The building is made in two parts. It's 18 by 10. The observatory itself is 10 by 10. And the remaining 8 by 10 is the heated quarter for winter. And my previous observatory, I had a furnace, oil furnace for light, for heating. Now I have electric heating. And we even, since my friend has a cottage, we also brought a telephone cable. So I have the telephone now in my observatory, which I found quite handy. Next, please. That is still my same old telescope, but I have, for many years, I had the intention of building a new equatorial. It's about 40% done now, and I hope by about a year from now it will be completed. And this equatorial will be large enough to accommodate a C14. I don't know if I will have a C14, but I would definitely like that my old Dynamax, I would like to make it the finder on my larger telescope, maybe someday. Next. So that is for my observatory. Now I would like to show some pictures I took in the last year or so. Those black and white slides, in fact, are made for, I first made a black and white picture. You see the side of the picture, it's 8 by 10 black and white picture. And to make the slides, I simply took photographs of the pictures with Panatomix X, which you can process as a slide. And unfortunately, well, I should not say unfortunately, I had the kit, Kodak for many years had that kit available. You can process a Panatomix X film into a positive instead of a negative. And I learned a couple of months ago that they have discontinued it. And I just had a couple Panatomix X film left, so I use it to reproduce a number of my slides. But since I have found that the T-Max film can also be processed as a slide, and they have here on the Bank Street, there's a place, Focus, I don't remember the exact name, but they have the photo center, they call it, on Bank Street. They have that kit. I checked there this afternoon. And so the T-Max, I was told that it makes better slide even than the Panatomix. So those of you who are interested can try it. So the sun has been very active during the last couple of years. I guess by now we have passed the maximum, but we will know exactly when it has happened in the near future, after we are sure it's declining. That was taken last year during the summer 1990. There was it was quite interesting to see this row of spots. Next. This one, I don't remember the exact date. I took too many, and when in a hurry last week, I decided to make some slides. I had not the time to look at each of them to remember the dates. But I know that spot, of course, was easily seen to the naked eye. Of course, when I say naked eye, it means at least you need a filter to reduce the intensity, but you do not need any optic to enlarge the sun. It was big enough, you could pick it up very easily. Next. That was this last August, about, well, just about a month ago. And I have seen that group just appearing on the side and pass in front of the sun. I was able to get pictures 4 or 5 times during the passage of those spots. Next. And too bad I had some dust on the negative, I guess, or on the paper. But anyway, this is one of the best pictures I have taken with my telescope. You can see quite a bit of granulation beside, of course, the large and the much smaller spots. Next. And that is about the best picture of the sun I have achieved so far. But during the last year, summer last year, and sometime during the winter, but during the winter, because the sun is too low, I have never been able to achieve that good pictures. But this one was shot last year, and this summer again I had a number of them as good as this one. And I found out that the best time to take them is before going to work in the morning. Because at lunchtime, sometime I go up to my observatory, but already the air has got warm and there is turbulence. But around 8:30 in June and July, the sun is already high enough, but the atmosphere is still cool, and you got the best seeing at that time. Next. This shot was taken about a month ago too. You can see quite a bit of facula. Of course, by making the pictures in my darkroom, because the edge of the sun is much less brighter than the middle, when you expose correctly for the side, suppose you want to take slides of the sun. If you expose correctly for the edge, well, the center will become overexposed or vice versa. But then, but if you do first a black and white picture, when you print the black and white picture, you can do dodging. You can, with a piece of cardboard, you can hide the surface so you don't need as much light as others area, and then you can make a better balance of the lighting across the field of view. And then you make the slide, which is, with that type of slide, you don't lose much of the information you have on your picture. Next. Some other objects, which are like this open cluster, is not observed very much. This cluster is in Cassiopeia. I don't remember, this is an NGC number. But it is as nice as M37, 38, but for some reason we rarely hear about those objects, simply because Mr. Messi did not put them on his list. But they are worth a look. Next. You all know this one. Can you improve the focus a bit? I believe it should be a little better. Okay. The next one. These are M16 and M17. This is an area just above the Sagittarius. Next. This is not M57 for the simple reason that M57 looks like a star in my Schmidt camera, the focal length is too short. That is the helix. The helix is larger than the moon, so it makes a reasonable large image on the negative. And of course, here this has been enlarged many times. But I was quite surprised by the result. Those two stars, and this one, are stars we see easily to the naked eye, and as well as the one up there. That means this object is, at this time of the year, is well placed in the sky. It's a huge, but we almost notice it unless we know where it is and we have a powerful binocular. I believe a binocular is much better than any telescope, unless you have a very rich field telescope, because the surface brightness is extremely low. But that picture was taken with 2415 hyper sensitized, and also with the addition of 25A red filter. 25A is quite red. It's about as red as the red there on those lamps. And so it blocks much of the light pollution, and also the sky is quite bright because of the sun activity. The sky might look dark, but actually it's bright. And Schmidt camera, it's a very fast optical system at f1.65. After 7-8 minutes without filter, it's completely dark. But with the red filter, it can go up to 20-25 minutes. So this is why I could get that much details in the helix. Next. This area has surprised me. I had read about it and seen pictures in magazine, but I was quite amazed by the result. Again, maybe the focus could be improved. That star, you all know it. This is Gamma Cygni, the star in the middle of the crux. And again, it's taken with 2515 hyper with a 25A red filter. You see how the hydrogen clouds glowing around. Next. And the moon is very red, as you can see. It is without filter. But, well, I mean without filter. There was a filter, a natural filter. You have certainly heard about all those forest fires we had in Quebec on the North Shore. One night, I was at my observatory at the end of June watching the conjunction of the three planets in the northwest. There was a huge, what I at first thought was a big storm coming, but normally storms don't really come from that direction, but I thought, well, that could be an exception, but no, it was smoke from the North Shore. So the planet disappeared behind the smoke, and eventually the moon was to disappear. Before it disappeared, I had the time to secure a couple pictures. So the moon was very high in the sky, but because of the smoke, it was extremely red. That is about 8-10-second exposure with Kodachrome 200. So that gives you an indication at f10. That gives you an indication how opaque the smoke was. Next. And the following morning, you see the ash in the windshield of my car. Considering that the river St. Lawrence is about 50 kilometers wide, you can imagine there was quite a fire on the North Shore. In fact, there was actually many big fires. So some days we completely lost the sun because of the smoke. It was quite impressive. Next. We have the eclipse now. That is just a couple minutes after first contact. Those pictures have been taken with a 200 millimeter telephoto with a Doppler, so for an equivalent 600 millimeter length. The sky was very clear at that time, at least the portion of the sky where the sun and the moon were. And I guess you have already seen pictures of Doug. Next. The filter I use is Mylar, so this is why we have a blue sun. Next. That is just a couple minutes before beginning of totality. In fact, second contact, I could not see it. It was completely clouded out. I might end of the soccer field, I don't know. Maybe at the other end someone could see it, I don't know. Next. So that was taken with my 50mm lens. You can see a bit of the sun, but I just wanted to show the state of the sky a couple minutes before totality. So the sun was really in the clouds. Next. And here we had the people. Well, that was very close to the beginning of totality, so wondering what was going to happen. And all looking west, because the shadow of the moon was to arrive that way. Next. And you see the mountain at the back. They're getting dark now because the shadow has reached that area. Next. And here you see the mountains are really dark, and we can just begin to feel the darkness. I would say, at least as far as I can remember, this is about as dark as it came during the eclipse. We could easily make an setup on the camera, write notes. It was bright enough. And the Sky and Terra report that it is about the brightest, one of the brightest eclipse. So that was my third total eclipse, and that was the brightest I have seen so far. So although it was long, the corona was so bright. Next. So I have some picture print, and I also have slide film. What happened, actually, the corona show better on my pictures, but the prominences show better on the slides. And here we see quite an arc of the chromosphere with a small prominence. It was very nice to look in binoculars. Next. So here it's a bit longer exposure, but there was still clouds. We see the inner corona, but you see that on this side we should still see the prominence, but it is hidden with just a little bit of it. It is hidden by the cloud. But there are quite an interesting one on the other side. Next. So this part is completely clouded, but we see the prominence quite well, and quite a bit of details in the corona. Next. This is about my best slide of the corona with the prominences on both sides. Next. Oh, I guess this one is quite close to the previous one. Next. And then we had the diamond ring, but it's almost only just the diamond because the ring is not very visible very much. Next. That was back in 1979, just to illustrate the kind of picture I was expecting to have. But too bad. I was quite disappointed at the time of the eclipse, but after I saw my picture, I feel better. Now also I feel even much better. I've decided that I will return to see an eclipse someday. I thought that would be my last one, but now I've decided I should, God permitting, I should see another one. Next. Okay, now we are going to we are the main subject of my talk tonight, astronomy, amateur astronomy, for fun and for science. Part of the fun of doing astronomy is showing, permitting, helping newcomer, people, adult or youth to look into a telescope. I'm sure many of you have experienced that, and people are always anxious to look at the moon or the planets, although they might be disappointed at the first look at the planets. But normally we try to make sure the moon will be around. So far I have never seen an adult or children not be impressed by the moon. Next. As I said, adult also. that picture was taken at one of those multiple solar eclipses we have along the years. That one was, I believe, in summer 1982. Next. Besides just looking at the planets or the moon and maybe recognize a couple constellations, maybe it begins to be a little more serious when we wonder what magnitude 0, magnitude second, third, etc., what it really means. And for a beginner, it does not worth mentioning those terms to them unless we show them some stars so they know what those terms mean. And a good place to begin with, because at our latitude, the Ursa Minor is always above the horizon. And when the sky is clear enough, well, there are stars from magnitude 2 to about magnitude 6. And of course, in Ursa Major, there are first and 0 magnitude stars. But beginning to be serious in astronomy about the sky is to learn to have a good hands about what the term magnitude means, and one place to begin with is with Ursa Minor. Next. This brings us to evaluation of the brightness of the variable stars, and this is the field where the amateur can easily bring contribution to science. You can have an EOI, binoculars, or a small or big telescope. There are variable stars for our way of life. And the AAVSO, American Association of Variable Star Observers, produce those stars, those maps of variable stars. They have maps for over 100 variables. And depending on the variable, they will have maps, let's say for naked eye observation, going down to about 5, 6 magnitude. And then you have maps going up to about 13, 14 magnitude. And some stars will vary 8, 10 magnitude. Then many maps can be used for that same star, depending its magnitude at a given time. Some other stars might vary between, let's say, 4 and 6. Then your naked eye is enough, and one map for such star would be enough too. I know your center here has a copy of most of those maps. So I hope they are used from time to time. And of course, I guess most of you are aware that those numbers here refer to the magnitude of the star. For example, 40 mean magnitude 4.0, 57 mean 5.7, etc. We don't put the dot because it would be confusing with the stars, of course. And this is Omicron. Or better known under the name Mira, which every about 200, well, this is 230, every 332 days come to maximum, and then it's easily visible to the naked eye, and then fade out of sight, going down to about magnitude 8, 9. Next, please. Well, I believe you recognize Fred. When I was here in Ottawa, I was fortunate because because of the help of Fred with his telescope and photometer, I could give first try at using a photometer to measure very precisely the magnitude of a star. And one night we observed an eclipsing binary. And I believe the next slide, the next one will show it. This is a close-up of the photometer head that Fred has built. There are 2 cables. One bring power, about 1100 volt DC to the photomultiplier tube, and the other cable bring the signal to the meter. Next. So I believe I've shown that picture at one of my talks not long before I returned to Rimouski. Anyway, for those who have not seen it, that is the data we got on that observation on that night. And that is the dots shows the magnitude as measured with Fred's photometer. And we have about 0.05 magnitude per centimeter. So of course, to the naked eye, you cannot make such precise measurement. But a trained observer can, I read that we can go about to 100 of a magnitude with a photometer. So I believe that we were on a good start. So I may continue someday with photometer, but this is very serious work. That was in May, on the night of May 7, 8, 1988, just before I moved back to Rimouski. Next. Observing comet. That could be fun. Just look at it. For example, we had Comet Levy last year. That one is Comet West back in 1976, which that one was very easy to look at. That is a picture taken with a 50 millimeter lens. That is, it's about the way it looks to the naked eye. You see the trees, the horizon. That was in March. We see the snow. And just put my camera on a tripod for a couple minutes exposure. And it's about close to what we could see to the naked eye. You see the tails was maybe about 15, 20 degrees long. Next. That is Comet Levy. That is a negative taken with my Schmidt camera. I was very fortunate. I have secured pictures of that comet 8 nights in a row. And during that period of 8 days, the tail has moved about 90 degrees, rotated about 90 degrees because of the change in geometry of the orbits of the comet relative to us. So that was quite interesting. And it would travel, I don't know, maybe 10 degrees per day. David's looks for comets. I believe there are 2 reasons. One is for science, and the other one, which I believe is a good reason to do it too, is because you can become famous discovering comet. Well, here you all know we have Rolf Meyer and Doug, who have in the past found a comet. So Rolf, I believe you have 3 so far? 4. 4, okay. And Doug, you got 1 or half one, something like that? That's good. But discovering comet also is science, because maybe amateur, besides discovering them, cannot do much, but the professional don't have the time to find them. So amateurs find them, and then they can turn their big instrument toward those comets. Next. And that is Levy at his observatory. And since he too has found many of his comets with that big telescope, although big telescopes have a reduced field of view, I believe, Rolf, many years ago when you discovered your first planet, you proved that a relatively large telescope could be used to find comets. And I believe this has been proved many times now, and all time I believe by Canadians. Your comets have been found with the 16-inch IRO telescope, and Doug also, and David has found, I believe, all of his with that 16-inch telescope too. Next. Shooting stars. They are fun to observe. I believe the Perseid are quite well covered. For a number of years, I believe TV and radio station all over North America want the public, invite the public to look at them. Certainly the public look at those objects only for the fun of it, but amateurs who can do a little more than that. Before I forget it, you will certainly recognize many of the pictures which I borrow from Sky and Telescope. Actually, I have asked Sky and Telescope permission to reproduce those pictures, which was granted. And I mentioned them that I was going to let you know about that. So the message has been passed. At the time, at the beginning of the space age, observing shooting stars was deemed very important because we were wondering about security of astronauts and other spacecraft, of course. And the National Research Council here at the Spring Hill Observatory made observing, very serious observing for many years with radar and with our sky camera. And there was also, they were operating a network of camera in the prairies. The US had a similar network, and there was one also in Europe. In North America, both Canadian and US programs have been terminated. So beside amateurs in North America, nobody really looks seriously to the shooting stars. Next slide, please. Of course, sometime those shooting stars would produce a meteorite. This is very rare, though, but by our observation, we may help finding those objects. On above time, I had the opportunity to touch a meteorite, and it is always with a special feeling to touch material we know that has been in space for a zillion of years, and now they are in our hands. Here, actually, that is a meteorite part of the national collection, which were kindly brought to meetings at some occasion by Ian Holiday. Next, please. I don't know. Is anybody here who has observed meteorite from that site? Okay. Okay, good. So for those who, just in case somebody is not aware, those coffins, as they used to call them, were heated box. The observer would get into the box, only his head poking out, and the warmth from the shed would keep him in good shape. And with the chimney was quite away, would bring the smoke quite away from the building, so they would not be bothered by it. And the member of the Ottawa Center have contributed a lot to the data accumulated by the NRC. When I came, while I was in Ottawa, Fred accompanied me to the site. Those pictures were taken at that occasion. Next. Meteorite, as I believe you all know, you have Jack Allwood here who does observing of shooting stars with his radio receiver tuned on a distant station. And here that is an optical sky telescope. A Japanese observer had accumulated data. Next, please. And here that is data that Jack kindly provided me for that talk. The principle works on the fact that the path of the meteorite ionize the upper atmosphere, which will reflect the microwave, so that a distant radio station or TV station, which normally you cannot receive because the signal just passes high overhead, then it is deflected by this temporary mirror, if you like, which can last a fraction of a second. But the advantage is that you can, that work, rain, cloud or not, or even in the day. And we don't know, from time to time new streams may appear, because many of those streams have been caused by comets. And if the amateurs don't make serious observation, new stream may come and go without being observed adequately, or sometimes just a sporadic shower happen, or some of the shower sometimes have very high extreme, and only the vigilance of amateur will catch that gain of activity. Next. Oh, by the way, there is now an international organization who collect data from observing shooting stars. I don't remember the name, but this is a name I should learn by heart. There's someone somewhere in northern Alberta who is part of that group, and he had an article in the bulletin, I believe in the last or second last issue. That is my old observatory with my old telescope. Just to illustrate the fact that we as amateurs, we take numerous pictures. Those pictures contain a lot of data. Unfortunately, most of that data will be never used because well, we accumulate pictures too fast, and also we to give them very thorough analysis would take too much time, which usually we don't have the patience to devote all the time needed. But anyway, sometimes there are calls for pictures in the Sky Telescope or Astronomy magazine if because someone saw something, or on one of his pictures he has something that he has seen only once, so he wants to know if somebody else somewhere has got pictures of the same area at about the same time or a couple of days before or after. So then you can dig up in your older pictures. So this is why an old picture sometimes may contain very serious information. And that information will be useful as long as you have the date and, if possible, the time the picture was taken. But at least have the date. Next, please. The planets are still worth observing. There is the Lunar Association of Lunar and Planetary Observers, and I believe there is still place for such an organization because, well, we won't talk about Venus because we amateurs cannot do much about observing Venus, and Magellan is at work there, and I don't think amateurs will ever beat the Magellan spacecraft. But concerning the other planets like Mars, Jupiter, Saturn, amateurs can do serious work there. For example, detect dust storm on Mars, or like last year the big white cloud on the surface of Saturn has been first detected by amateurs. Of course, again, the professional came in and could make more serious observation, but they did not have to lose their time watching. They know that the amateur is doing it, and when something interesting happens, they will be warned, and then we all know even the space telescope was turned towards Saturn. Next. Last year we saw a band disappear. One of the bands disappeared completely on Saturn, and again ALPO observers have been the first to notice the disappearance of the fading of the band. But ironically enough, when the band was gone, the famous red spot on Jupiter was much easier to see. In my scope, I had never seen it so that easily, and some people who told me they had never been able to see it, and even I had doubt they would ever see it in a small telescope. They were amazed how easy it was to see. But 5-6 months later, the band was back, and the red spot was quite difficult to see again. But anyway, it seemed that when we lose the band, we gain the spot gain something. Next. Those maps appear on the average, I would say, every 2-3 years in Sky and Telescope. It's helped those observers of Jupiter and Saturn. There is a similar one for Saturn. The main bands are identified, and the changes those who like to make drawing can easily add the changes on that form. And that form has been produced by Association of Lunar and Planetary Observers. It might seem dull watching the planet, but for those of amateurs stranded within a city, maybe if they want to be serious, this is one of the fields they could work in. Next. Even occultation is not out of fashion yet. There is this International Lunar Occultation Center in Tokyo, which they welcome observation of occultation by the moon and by asteroid, of course. I believe it was spring 87, April 1987. While I was here in Ottawa, we had a nice occultation of Venus by the moon. I did time it, and I sent my report to the IOTO, which stands for International Occultation and Timing Association Observer, something like that. And in turn, they sent it to International Lunar Occultation, and this latter group sent me their last report. And from what I read in their report, they looked very seriously at contributions from amateur. When the moon crosses an open cluster, for example, the Pleiades have been crossed many times during the last couple of years. It's fun just to watch the bright stars disappearing behind the moon, but you can give it a quite scientific dimension by adding the timing on it. There are also grazing occultation. I know here Brian Berkey. I don't know. Are you still active, Brian, arranging those expeditions?
Yes.
Yes? Okay, good. So I don't say more about it. You all know what it is. Next. Timing of Jupiter satellite also are still welcome. And again, on the period, though, every 6 or 7 years, I believe, the Earth passed just in the plane of the Jupiter equator, and at that time, the 4 main satellites occurred and eclipses each of them regularly, very often, and that could be fun just for to watch. But again, if you do it, please time it and send your data to the required place. Next. For those who observe the sun or would like to know the chance that there might be bright aurora, well, I suggest that you read that article in Sky and Telescope. Unfortunately, I forgot the exact issue of Sky and Telescope, but I have a list. All the I have read. I went back about 22 years back of Sky and Telescope to get information on the project for serious amateurs, and I made a listing of all these objects. And I was supposed to have copies to give to your center. I forgot it. I apologize for that, but I will mail a copy to your center. So if someone wants to read any of those articles, you will have a complete listing of it. And this one here, I believe, quite important. It provides, give the information which will permit you to interpret the bulletin, which every 18 minutes past the hour on WWV, 18 minutes past the hour, they provide a bulletin which lasts about 15-20 seconds, but it's very brief. But in order to understand what those numbers mean, you need to read the solar alert. And I suggest you prepare a form. Based on that reading, prepare a form. And then as the information is sent, you listen to the information, you just fill the form. It can be done very quickly. Next. You can even build again, just for the fun, a small device. It was, as they say here, for about $3, which will permit you to measure the change in the magnetic field of the Earth, which in turn depend on the relation of the between the Sun and the Earth. When the big storms eruption happen on the Sun, and if the matter spewed out by the Sun is sent in the direction of the Earth, there are interaction with the magnetic field of the Earth, and then we have what we call magnetic storm, which cause beside the problem they cause with shortwave communication, they also generate those nice aurora borealis. So when you see your device, if you build one, you see your device that is beginning to move, it means that there is activity going on. So the following night you may check for aurora borealis. Next. And the guy who built the previous device has taken data of the big storm that we had in March 1989, the one which kicked down the hydropower in Quebec. So I was fortunate the day before the power failure, I had taken a picture of the Sun. I have pictured that very bright spot, naked eye spot, and the day of the failure, we could not go to work, so I had time. The sky was clear, so I shot the following picture. Next, please. So you can see the spot. So a couple of days after that, I had made print and bring it to the office to show to my colleague, and more half a joke, half serious, I told them that might be the cause of the power failure. Everybody laughed at me, but a couple of months later, it was admitted that that was the real cause. So I was quite happy to have those pictures. Next. For spectrography, spectrum of the stars is interesting in itself. You can learn much from the star with a spectrogram. But I came to the conclusion that unless you have a large telescope and you can dedicate much time taking those pictures of a spectrum and then analyze them, and I am afraid in order to have enough diffraction, well, not many amateurs can have that. I believe, Rob, you do that, don't you? Do you have a spectrogram?
Yeah, whenever I can, whenever it's clear.
Yeah, okay, good. So I believe you are only some of the very few who does that. Do you know others in Canada who does that?
I don't know anybody as an amateur, because as you mentioned, you need a rather large telescope to feed it. But as it is, I can reach down to about 8 magnitude, which is quite
Oh, okay, very good. So I was going to say almost no matter does that, but I believe I was right. So we have only one in Canada I'm about sure about that. Anyway, I'm going, as I go, I do my tour of the centers. I ask the question. So far, this is the first one I have confirmation of. And anyway, this is a subject that need quite a large investment in money and time. So I don't think we can compete, many of us can compete with the professional. But you can do, for example, you can buy a prism and put it in front of your camera, and you will have some crude spectrum or a diffraction grating, like the next slide will show. Again, you may recognize, some of you will remember those pictures. I believe I had shown him previously. I simply put a diffraction grating a couple inches in front of the film in the focusing mount of the telescope. And that is Jupiter, and the spectrum we see is spectrum of the sun, reflected light of Jupiter. Next. And the spectrum of Rimouski. You can see the mercury lamp. That picture was taken about close to 20 years ago. So there were almost only mercury lamp. Today we have many sodium lamp. And this is about the area of my house. That picture shows Rimouski worse than actually it was at that time, because that was quite a long exposure. But today is probably close to that. Next. Robert Evans in Australia, for a number of years, is discovering supernovae in external galaxies. He has learned by heart the field of view of hundreds of galaxies, and so he can quickly go from one to the other. And if something new, new stars happen to be there, he spot them. So he discovered, I believe, on the average 2 or 3 a year, and this has been going for a number of years. So of course, again, he cannot do much besides discovering them, but that is quite a bit, because then again the professional can turn the big instrument. And there are many professionals who are interested in those supernovae. You all remember the one which was discovered, the brightest one for centuries, which came in 1987. But of course, any supernovae visible in amateur telescope is certainly much easier to see in professional telescope, and then they can study those stars. And because of the discoveries made by Robert, the science has made a lot of progress. And it is unfortunate that it seems nobody in the northern hemisphere, and we know that the majority of the amateurs are in the northern hemisphere, it seems that nobody has taken on him of doing similar observation in northern hemisphere. Because if there was somebody looking seriously at it, he would have discovered some already. So if you are interested to become famous and at the same time help science, this is something you could do. Have a big light bucket and look at the galaxies. Next. This is the AAVSO alert notice for, I believe, $5 or $7 a year. Each time something special happens, the AAVSO will mail you this alert notice. So I hope some of you receive it. Has anybody received it here? No? Well, I encourage you to do so. And even better, if you have email, and probably some of you do have, I have highlighted one of their email address, but the one, I made a mistake. At least from my email address, I can reach them. They have two. The one at your right is the one I believe you can reach with a bitnet. So that means if they have something important, they will put it on their email, and if you look at email that same day or that within the same hours, you will instantly get that information. So I encourage you to do so. And in those alert notice, I believe for the last 2-3 years, every alert notice will have 2 or 3 notice, but at least one will have to do with space probe. For example, when the shuttle went up with Astro 1, the AAVSO observers were asked to observe a number of stars, because of course their instrument cannot look at all the stars. Even professional underground cannot either, but hundreds of amateurs all around the Earth can make a continuous monitoring of those stars. And if something happens, you call the AAVSO or the NASA, and 5-10 minutes later, the big scope within the shuttle will be aimed at the same star you might still be looking at. So think about it. It's quite interesting. Next. And again, in the case of even the observation for space telescope are continuously asked from AVSO members. So I have the feeling that variable star observing is dying, and certainly much less popular than it used to be. And I hope it will have a comeback, and probably CCD will help. So I will say a little more later about that. Next. And more serious amateur can even have their pet project use the space telescope to run it. A couple of years ago, a number of given quantity of observing time was given to amateurs, and 6 projects have been retained. And a couple of months ago, there was another announcement for more time to be given to the amateurs. So I hope the gyroscope in the telescope will stand long enough so those amateurs projects can be fruitful. Next. Asteroid is another domain where the amateur can do something serious. For myself, I remember not long after I started observing the sky, I decided, well, I should look some of those minor planets. Of course, with the Observer Handbook, a number of them are, the information is available. A sky telescope regularly has maps to find asteroids. So it's fun to watch them and to have the proof for ourselves that yes, they really exist. They move like the backward and then forward like the main planets, but they also rotate on themselves. And with a photometer, which can make quite precise measurement of magnitude, you can measure the period of rotations. And probably, Rob, is something you could do, make many pictures, many exposures of the same object at a time when sometimes move quite fast. And in the matter of 10-15 minutes, they have moved enough to take a new picture. So that was taken, that is a rose in 1975. That is a picture I took again in Sky and Telescope. There was 15 minutes between each exposure, so you can see the rotation. You can compute the period of rotation of arrows from that picture series of exposures. Next. And the diameter can also be measured almost directly if many observers at different locations observe, for example, an asteroid occulting a star. And again, the Observer's Handbook contains prediction for many of those objects. Well, here we have, you can do it to the naked eye, and of course you need precise timing of your observation, but a photometer is even better. You can analyze later, and that will make it more precise, but still it can be made to the naked eye. Next. Observing occultation of stars by asteroid now about 12-15 years ago, amateurs claimed that they had seen multiple occultation, which they interpreted as asteroid with satellite. And they were not taken seriously by the professionals. But this has been observed a number of times by serious amateurs, and they were convinced the thing existed. And much more credit was given, I believe that was last year or the year before, when a new asteroid came to pass relatively close to the Earth, and with the Arecibo radio telescope, they have been able to resolve the object, and what they saw, like a dumbbell, 2 spheres connected together, turning on itself. So it's rough, but definitely the resolution is good enough. They are sure there are 2 small objects just stuck together. Because the gravity is not strong enough. it won't become a ball, a sphere, because the gravity is not strong enough. But it means before they became in contact, probably they have orbited their center of mass for a long period of time. The argument of professional was that those, because of the small attraction of those bodies, unless they are very close to each other, the tide effect of the sun, because their orbit is often quite elliptical, or the attraction of the big planets would disrupt those systems. But I believe, to me at least, this is that it proves that some of them could be close enough, they will stay together, and even sometimes spiral toward each other. But probably in order to happen, but maybe again they had some effect, tide effect from the sun or the planet, but instead of disrupting the system, it went the other way. They coalesced together. So more observation by amateur could detect, multiple observation by amateur would be additional proof that those minor planets do have satellite. Next. Micrometer can be used for measuring separation between double stars. I don't think this is a field where very attractive to amateurs, but some of us may have interest doing it. If you have interest, well, although you might be the only one in Canada, like Rob with his spectrograph, well, do it. As Paul Commission was telling me during the dinner, the fun for amateur, you do what you like to do. The professional, well, he has a program to do, and he has to do some precise work because he is paid for, and they have boss who tell them what to do. But a micrometer also could be used to make measurement, precise positioning of the core of comet or asteroid, because still many asteroids don't have permanent number because they have not been observed well enough. Their orbits is not known well enough, and in order to improve that, very precise position at very precise time have to be accumulated for those objects, and amateurs can help with that. Next, please. And for example, instead of a micrometer, as was explained in sky telescope, by enlarging your picture up to 11, 14, for example, with a millimeter rule, you can make measurement directly on the picture. And since many amateurs can easily reach 12, 14, 15, and Rob even up to 19, 18th magnitude. So that means thousands of asteroids can be watched by amateurs. Next picture, please. Maybe a better way to do it is make the measurement directly on the film, but then you need a very precise instrument. But again, this is something, if you have a mechanics among your friends, this is something you could have built. I should add, in Canada, we have Chris Pratt of the Victoria Center, who does just that, precise measurement of asteroid and comet. And yes, Doug? Oh, okay. I was just going to say something about that, so I will ask you to add to what I'm going to say. Chris Pratt, maybe some of you know, maybe you don't, recently had an asteroid named after him, just because of his many years of work on asteroid program and comets. So the name is Spratia. Next, please. So I am at the very end. The CCD, I believe, is the future, not only for professional, but for amateur. And as Doug said, he planned to do positioning measurement of object. And I guess are you working on developing software for that work, Doug?
It's mostly working. I think I have one bug left.
You have, okay, you have work, you believe you have one bug, but you already have quite a bit of good software developed.
Yes, well, I don't know what good if it works.
Oh, I'm glad to hear that, okay. Because this is one of the things I will probably do eventually, well, both maybe astrometry and photometry as well. And, but I want to work on software. I don't like it, and I don't think I have the knowledge to do it anyway. So other people like you are kind enough to do it. So I understand that your program based on is it photometry or astrometry?
It's astrometry.
Astrometry, okay. So providing the coordinate to the software on a number of stars, it compute the location of the object?
Yes, because of the small field of view, I have to use the Guide Star catalog. The Hubble telescope Guide Star catalog.
Ah, okay. Okay. And with the as for photometry, the nice thing about it is that in one shot you could have, well, let's hope the CCDs will be a bit larger than they are today, but you can on the same shot have the variable and the reference stars, and then the software would compute the magnitude of your star instantly. And there will be at the next AAVSO FAR meeting this October, in a month they will have a symposium on that precise subject. And it will be a joint workshop with IEEE people. What the AAVSO hope and vision is that IEEE they develop technique, and of course software is part of goes with the technique, but the AAVSO don't want to get involved with that, so they hope the IEEE will make this available, but then AAVSO will suggest program and will prepare reference stars and so on for such program, and perhaps make special filters available to those who want to make photometry with CCDs. So I believe as of today, for example, this picture was provided to me by Chris Brown of the Winnipeg Center, and Fred was telling me before my talk that here some of you are using CCDs, and I know in Montreal a couple of guys have one, in Quebec City, and certainly more will have CCDs, and better CCDs, better computer, and so on. As for now, I have a personal opinion on that. I like seeing all of you working on that, and I hope you will continue, because I believe because of this early work, I hope 3-4 years in the future we will have better device available and also software available to the mass of amateurs. And then I believe the amateurs photography will still be important, because our 12, 14, 18-inch telescope become as powerful as big telescope of 10 years ago. But by the same token, I hope that we won't just pile up discs. We used to pile pictures, now we are going to pile discs. But I hope we are going to pile real data, and the pile will be much less, because when we start piling pictures, well, maybe we won't have room to put all those disks in the future. And also, again, as I said earlier, pictures contain a lot of data, but what is the point getting data and just let them accumulate dust? So I believe the CCD will give a second life to variable star observing, and also improve, maybe give much amateur involvement in astrometry. I believe that is two domains which need much help from the amateurs, because the professional cannot spend years to watch a small asteroid or a variable star. They need to publish at least once a year. We can do it only once in our life or never in our life. We just give the data to somebody else, who will publish his work and put your name on his paper. For example, IAPPP members, many of them amateurs, have made serious observing, but they don't have the time to reduce the observation and make, even though they wanted to send their article to astrophysical journal, well, they will be turned down. But professionals who use that same data won't be turned down, and your name could be put in those well-respected magazines. So I believe that is the last slide of my presentation. If you have some question, I will be glad to try to answer. But I know here that in Ottawa, exceptionally, many of your members are already active in some of the subjects I have talked about. Thank you very much.
Well, how about it? Are there any questions, Damien?
Yes, Paul?
I wanted to ask you two questions, Damien. First of all, I want to know what the interface is between the professional astronomers and the Royal Astronomical Society of Canada. Because I'll tell you why. In the years that I've been around in Ottawa here, I've only noticed two professional astronomers asking amateurs for help, or whatever you want to call it. And that was John Percy on the AAVSO, but he was general. He just said, it's nice to observe, help us observe all the variable stars. And Paul Feldman of the Hertzberg Institute asked us about 3 or 4 years ago to observe that thing in Aries, that flasher, or whatever it is that the North York people had. And I remember myself looking there. I didn't see anything, but that's the idea. I think that by virtue of having something like the newsletter, that you're in touch with all the professional astronomers, they could easily ask people things like Feldman asked, we have such and such a thing. Could you people do it and send your answer to the newsletter or something? I feel that there's maybe not you're one of the few. All right, you tonight. So there's 3 people that have asked the amateur to pitch in. We don't get enough of that.
Well, for one, I must say that I am a bit disappointed not to see more professionals being part or active within the RASC, although we have many good ones. For example, Lloyd Higg, who is a radio astronomer, was president before me, and I believe he has been active here in the center for many years, and I believe he will always keep in contact, in touch with the amateurs. John Percy is another one. As you mentioned, he is presently president of the AAVSO, and he is in close contact with IAPPP as well. And of course, he teaches astronomy, so he would like to see more young talents going toward astrophysics. But among the professionals, we have also Doug Hugh, second vice president of our society. We have a number of them. And I must say the situation is not as bad as I thought. I have checked with Rosemary Freeman, our executive secretary, and CASCA has about 250 members. About 90 of them are members of the RASC. So this is about 30%, which is not bad. Of course, it could be better. We know that at the time of Mr. Chant, maybe 40 or 50 years ago, I believe all professionals in Canada were members of the RASC. But of course, at that time, the RASC was much more prestigious than it was at that time. First, because astronomy was not as popular. There was no other organization, society in Canada. So our professional belong to the at the RASC, and also it was the professional were almost all concentrated in Toronto and Victoria, so that makes it much easier. But of course, along the years, the amateurs became predominant in the RASC. I believe 50 years ago, it would have been difficult to have an amateur become president of the RASC. I am very proud of being president. Looking back at all those important people who have been president, I could not dream that someday I will be there, but I believe I continue to be an amateur, and this is partly why I put some of pictures of my new observatory and recent pictures I have taken. In the future, well, I have written a letter of invitation to CASCO to be published in their publication. I understand it has been inviting them to become members. I don't know if it will have any effect, but I believe the professional now who wants data, instead of coming, let's say, directly to the RASC, whatever they are, they will go to international organizations like AAVSO, Association of Lunar Planetary Observer, IOTA, and so on. And the AAVSO receive more than one request per day, a working day, because last year they received over 200 requests. So that means almost 2 per working day. So that is the place, I believe, if the amateurs all over the world, they address their requests. Fred?
Comment on your question, Paul. I think the strongest interaction that ever took place was between Peter Lemay and the amateur observers such as Damien, Mary Henderson, Mary Graves, many others whose names I don't recall. That was a very strong interaction. These people went out by the hours, to observe it. And it left its legacy among to a point, and people who did the today being carried out by law. So this is another very strong interaction with the professionals. Even all the major professionals cease now, unfortunately.
Yes.
This is an opportunity for them to get sort of free help, if you want to call it that, because here are people that are knowledgeable in the subject. You don't have this in too many other sciences. Here you have people that are knowledgeable in the subject and have fairly good equipment. You know, things that professionals used 25, 30 years ago. Right? People are equipped with good, like Rob Dick has a professional telescope, version of professional, and things like that. Well, these things could be put to what you would call a more professional or online use.
For example, Walt, do you have any overlap with the media astronomers?
I'm not aware of any work that they're doing in that area any over 5.
And of course, we should remember Ellen Hogg, who has been a great professional, and she still has close tie with the RASC. So let's hope we will continue to have people like her in the future. And Peter Millman, of course, all his life, I believe he was the oldest member of the RASC before he passed away.
Now, mind you, there's Aurora work now going on, isn't there? Are amateur observations useful in that area?
What we tend to do, we have networks of instruments in northern Canada.
Of course, that's where the Aurora is.
We tend to get a whole battery of instruments observing single events. I don't think the other observations are really enough to do.
How about some nice pictures?
Rob?
I think something, Damien, you mentioned, let's go and have fun. Some people, that have actually gone a great deal of difficulty trying to address or answer some requests for data that professionals have put out in a rather unfocused way to general astronomers, amateur astronomers. And usually the data doesn't get treated very well because a lot of the traceability in the data, the way of handling data is pretty send the information, please get it out of their desks, as you say, from gathering dust, then really they've done more than enough of their part. As long as there's a medium, perhaps the RAC journal or other publications, where they can send this information. And I agree, sending it to AppJ is not likely to see much light to send it into a magazine like that or a journal like that. But if there's other avenues for it to go to, for example, the IEEE journal, the ADSL journal, all these people accept
Yep.
amateur quality work, and a lot of that amateur quality work is professional level, some of it, and very creative too, I think.
Mhm.
Any other questions? Okay.
Okay, anyway, I will be around if you have other questions.